Hey guys, Keith asked me to share with everybody a strategy that I use for graphing solids of revolution. And since we ran out of time in our meeting today, I thought I'd test out my new screen capture software and show you guys how I do that here. So I'm just going to talk you through how I help my students visualize this, and hopefully it'll help you if you have trouble drawing some of this stuff in our upcoming unit. So I have a pretty straightforward example here with just a nice quadratic that is going to define our region, the region bounded by that curve in the x-axis. So right here in quadrant 1 is what we're looking at. And in this first part, I'd like to spin that around the x-axis. So what I tell my kiddos first is just to let the reader know what you're spinning around with a nice little arrow like that. That really communicates that to everybody. And since it's really hard to visualize what happens when I take that entire region and spin it, if we can just capture one representative rectangle, that should do the trick. So we can draw that rectangle anywhere. I'll put it over here for right now. And for my kids who maybe aren't the best at drawing, to really simulate this spin, I try and ground this in the idea of just taking that one rectangle and reflecting it over the line that we indicated as our axis of revolution. So that means they should draw an identical rectangle, like same height or as close to that height as possible, but flipped over this line. So in this case, that rectangle comes right around here. And to simulate the spin, we just are going to go from the top of the original rectangle that we created out and down to the bottom of its reflection. So something like that can really demonstrate to students that a disc is going to be formed. I never try and draw the entire thing because I'm not really into that three-dimensional stuff. I've never been able to draw it, but I think this helps me see a lot that I'm going to have a little disc there that I can see the radius quite clearly, and then we can have conversations about top minus bottom and go from there with our integral. So similarly with part B, you want to start just by reminding the children to communicate to their reader what it is that they're spinning around. So in this case, we need to draw in, can't draw a straight line, sorry, the line y equals -1 and tell everyone that that's what we're going to spin our axis around. Sorry, that's my dog freaking out. So anyway, I'm going to draw one representative rectangle again and try to really drive home the point that if I just reflect that rectangle over this line, I can simulate the revolution that's going to occur. So just reminding students that a reflection should be an identical rectangle, equidistant, I guess, from that axis, but on the other side. So somewhere down here in this case, and I can never draw them to look exactly the same, but they get the idea. And then to do the revolution, I'll go from the top of my original down to the bottom of its counterpart, and same thing with that inner piece as well, bottom of my original to the top of the reflection. And they can see that the solid is going to have a hole in it, which leads us into conversations about washers. Oftentimes I will try to demonstrate that that outer circle's radius is the distance from here to the axis. We can have conversations then about top minus bottom, inner radius from the bottom of our rectangle to the axis. And we can go from there in doing the calculus and setting up our integrals. Last one real quick around the y-axis. Just know that then our rectangles are laying on their side, but the idea, hopefully you've gotten it by now, is the same. Reflect that rectangle and simulate the spin outer edge to outer edge and inner to inner. And we've got another washer that's formed. And if you're wanting just one more visual, the outer radius here would be from that outer edge to the axis. The inner is right around here. So that's that. It seems to have worked for my students, and hopefully it can help you if you have trouble drawing these things. Feel free to shoot me an email if you have any questions or need any support. I would be happy to help, and y'all have a good weekend.